Let's do that last problem, part C. So we have 2 to the x plus 1 minus 5 to the 2x minus 1 equals 0. And we'll solve this using the same methodology. We'll have to get our equation in a slightly different form. That is, we'll have to rewrite it by adding 5 to the 2x minus 1 to both sides. And we'll get 2 to the x plus 1 equals 5 to the 2x minus 1. But what is important, as we noted before, is that the rewritten equation either looks like a power or a number to a power involving x equals another number, or a number to a power involving x equals a number to another power involving x. And that second type is exactly what we have here. Then we'll follow the same steps that are outlined. We'll take the logarithm of both sides. You can choose which one. So I'll do natural logarithm on this one. And here we'll have two places where we can apply the logarithm properties. This x plus 1 will drop down, and this 2x minus 1 will drop down, so we get x plus 1. Remember, if there's a plus, make sure you put parentheses when you drop the exponent down, equals 2x minus 1 ln 5. This one is slightly more challenging because you have x's on both sides. Let me remind you, when you have an equation that has x's on both sides, then you have to get everything that has an x on one side and everything without an x on the other. So 2x minus 3x, subtracting 3x from both sides and then subtracting 1 from both sides equals negative 1 minus 2. Now you can factor an x out of this left-hand side and you get x times 2 minus 3 equals negative 1 minus 2. And I do know that you can simplify 2x minus 3x to be negative x, but trust me, it's useful to do it in this way for the problems that you will be working. So yes, over here where I've marked star, you can simplify that as negative x, but it will be helpful to view it this way for now. Then you divide both sides by 2 minus 3, and you would get x equals negative 1 minus 2 over 2 minus 3. And this expression you can simplify easily. Negative 1 minus 2 is negative 3. Divided by negative 1, that's just going to be positive 3. So remember, get all the x's on one side and then factor out an x. So let's do that here. Now, here I'm going to go ahead and distribute this ln2 because in my problem, my reminder problem here, notice that there's nothing multiplying both sides. So I want to make my problem that I'm working on from part C to look as much like my reminder problem here. So I distribute this ln2 and distribute this ln3, and I get x times ln2 plus ln2 equals x times 2 ln 5 minus ln 5. And now I'll go ahead and apply that same methodology that we saw over here in factoring out an x once I get all the x's on one side. So let's subtract x times 2 ln 5 from both sides. And let's subtract ln 2 from both sides because I want to get everything with an x on one side, everything without an x on the other. If I do this, then my ln2's will go away on the left-hand side, and on the right-hand side, the term with the x's will go away. So what I have that results is, let's see, x ln 2 minus x times 2 ln 5, x times ln 2 minus x times 2 ln 5 equals, and what was over here? Negative ln 5 minus ln 2. So negative ln 5 minus ln 2. Now I can factor an x out of this left-hand side, and I get x times ln 2 minus 2 ln 5 equals negative ln 5 minus ln 2. And then I'll divide both sides by whatever x is multiplying. So ln 2 minus 2 ln 5. And now maybe you can see why in my example problem I wrote things the way that I did. That seemed a little strange because, well, in our problem we can't simplify this. I suppose we could use some log properties to simplify it, but we can't simplify it in such an easy way as to say that 2 minus 3 is negative 1, right? So this doesn't simplify to just some easy number, and that's why I wrote things so strangely in my example problem. So there we go. There we have our final answer, negative ln 5 minus ln 2 divided by ln 2 minus 2 ln 5. We'll just leave it just like that.